Hello everyone, thanks for your interest to this talk. Today I am going to speak about access control model of Linux native performance monitoring using Linux Perf tool as one of possible examples to demonstrate the model in action. But first, short intro of myself. So my name is Alexey Budankov. I am former Intel software engineer who drove development of driverless analysis flow for Intel Vitium Profiler product. And this talk is actually inspired by the results achieved for the sake of driverless Vitium customer needs. Linux native performance monitoring and analysis features have been available for more than 10 years already, starting from Linux version 2.6.32. This part of operating system is mature enough, with established and documented processes of development and deployment, existing documented procedure of hardware bugs mitigation in Linux kernel source code, makes usage of performance monitoring features even more manageable and predictable. However, existing access control mechanisms for performance monitoring features are still not flexible enough, and that limits adoption of native performance monitoring in security-sensitive production environments. So, the main motivation of this talk is to socialize existing perf access control mechanisms to broader user and developer community, boost perf-based tools adoption to security-sensitive production environments, and make connections to the community to get feedback and discover demand on possible extensions to Linux native performance monitoring and observability features. Access control is applied to subjects, either active entities or actors, when they try accessing some objects whose accessibility is required to be managed. This relationship is presented in the right part of the slide. In Linux, subjects are processes with their unique IDs, like user ID, group ID, etc., and the processes can be actually differentiated using that IDs. Controlled objects are performance data captured from OS and hardware via perf events kernel subsystem and via other subsystems also providing performance data. Access control mechanisms provide configurability and check which processes can access this or that performance data by means of related kernel subsystems. And its performance monitoring features are controlled by several access control mechanisms listed in this slide. Operating system also checks and controls amount of resources allocated and used for performance monitoring. Performance monitoring can be available to processes in different scope and at different level of execution in the system. To perform security checks, Linux implementation split processes into two categories. That is, privileged processes whose effective user ID is 0, root or superuser processes, and unprivileged processes whose effective user ID is non-zero. Privileged processes bypass all kernel security checks, so perf events-based monitoring is fully available to privileged processes without access, scope, and resource restrictions. Unprivileged processes are subject to full security permission check based on the process identity, like user ID, group ID, and other user groups. Linux divides privileges, traditionally associated with superuser, into distinct units, known as capabilities, which can be independently enabled and disabled on per-thread basis for processes and files of unprivileged users. Unprivileged processes with enabled CAPPERFMON capability are treated as privileged processes with respect to perf events monitoring and observability operations, and this way bypass scope permission checks in the kernel. CAPPERFMON implements the principle of least privilege for performance monitoring and observability operations in the kernel and provides secure way to conduct monitoring activity in Linux. Perf tool suite provides broad spectrum of features for observability and performance monitoring of workload, operating system, and hardware. Scope of features varies depending on hardware running kernel and tool version. However, basic features are available for majority of hardware architectures supported by Linux. To list a few of that features, Perf provides functionality to capture trace points, monitor kernel events. There is integration with eBPF framework, monitoring of events in CPU microarchitecture, and Encore part of the system is also available. Mentioned functionality can be applied in various scope, either to monitor some selected process, to monitor several processes belonging to AAC group, or to monitor the whole system. Monitoring can be conducted at the different levels of execution in a system. Either monitoring of user mode activity of process can then be expanded to monitoring kernel level activity of that process, and eventually monitoring can be expanded to hypervisor level of execution in the system. Thus, performance data accessible via existing performance monitoring features being applied in various scope and at the different levels can be treated as data residing at some informational space with access managed by the OS access control mechanisms. Operating system implements control of resources used for performance monitoring. System checks consumed CPU time, amount of memory, and number of allocated file descriptors for process conducting performance monitoring. Control of CPU time consumed for performance monitoring is implemented by means of perf event max sample rate and perf CPU time max percent settings. Max sample rate defines max available sampling frequency available in the system, and max percent defines percent of CPU time available for data collection and processing. System calculates average time spent to process a sample, and in case this time overcomes percent threshold defined by max percent value, system lowers sampling frequency to keep system responsive during performance monitoring. This kernel activity can be observed in output of DMS command like presented in the top of the slide. Monitoring of profiling overload can be disabled by setting max percent value to 0 or 100. However, max sample rate is still applied, and if sampling frequency gets high, this leads to the fact that samples are captured at the beginning of scheduler tick only, and the other part of tick remains not sampled. This system behavior can lead to lowering accuracy of provided performance data because they are captured only at the beginning of the scheduler tick. Amount of memory available for performance monitoring is managed by perf event mlog setting. This setting actually defines amount of memory available for monitoring one CPU by all processes belonging to a user that conduct monitoring simultaneously. Either the more processes monitor performance, the less the amount of memory available to each process. And moreover, in this case, the memory allocation and distribution between processes should be made explicitly. And a map pages option of perf record mode can be actually used for that. Otherwise, perf tool can print message presented in the middle of the slide about no memory available to conduct monitoring. Processes can be provided with memory above established mlog limit by granting cap IPC log capability. Perf event open system call that implements monitoring returns file descriptor in case of success call. In case of large number of such successful calls made by process, the process limit of open file descriptors can be easily reached, and this situation is actually quite common and happens in case of monitoring big number of events on machines with big amount of cores. File descriptors limit can be actually enlarged by setting big enough value at limits.conf file. And necessary value for this limit can be calculated by multiplying amount of events to monitor by the amount of available CPU cores. In case of any access limitations to performance monitoring features in the system, perf utility prints the message presented in this slide. Access control is implemented by several mechanisms available in the kernel. It is mandatory access control, discretionary access control, and system control perf event paranoid setting. Control is applied in a hierarchical manner. It is mandatory access control can limit access, open it at discretionary access control level and at perf event paranoid file. LSM hooks for mandatory access control are enabled for perf events kernel subsystem starting from kernel 5.5. Enabled hooks control configuring and reading of counters, control reading of trace point data, control reading of performance data from kernel level and in the scope of the whole system. For kernel 5.7 and older, full access to performance monitoring is available to root processes and processes with CAP sysadmin capability. However, providing processes with CAP sysadmin capability is considered insecure, and thus, starting from kernel 5.8, performance monitoring privileges have been made accessible to processes with CAP perfmon capability. That was especially introduced for that. Using CAP perfmon capability provides secure way to access performance monitoring features without functionality limitations. CAP perfmon provides access not only to perf events kernel subsystem features but also to other kernel subsystem features implementing performance monitoring performance data collection. For instance, to subsystems providing data for performance of GPU and FPGA. Other Linux capabilities can provide access to auxiliary data useful for performance analysis. For instance, CAP syslog opens access to content of proc KOSIM data, and CAP sysraw.io opens access to content of physical memory via proc kcore file. Perf event paranoid setting controls access to performance monitoring for unprivileged users of the system. Actually, perf event paranoid setting is a number that defines available scope and level of performance monitoring at the same time. Current version of mainline kernel supports 4 possible values of paranoid setting, and -1 means that monitoring is available without scope and level limits. Memory limit is also lifted, however, the limit on amount of open file descriptors is still applied. 0 means that monitoring is available without scope and level limits, but usage of trace points is prohibited. Limits on amount of memory and open file descriptors are applied. 1 means that monitoring is available in the scope of user processes and without level limits. Limits on consumed OS resources are applied. And 2 means that monitoring is available in the scope of user process and only at the user level of code execution. Limits on consumed OS resources are applied. Actually, this value 2 is usually the default one in the mainline kernel version and the most probable setting of paranoid in production environment. From the table in the slide, it can be seen that configuration capabilities are not flexible enough, and production systems tend to limit access to performance monitoring features for the majority of unprivileged users. Usage of Linux capabilities can actually extend configurability of access to performance monitoring of Linux, and at the same time it preserves security level established by perf event paranoid setting. Linux capabilities, jointly with file access control mechanisms, provide a way to create groups of users privileged for performance monitoring. For that, just create group with name perf users, for instance, and assign it to perf tool executable like demonstrated in this slide. Then limit execution to this perf executable to owner and perf user group members only. Finally, grant perfmon capability and any other capabilities to that perf executable in order to provide perf user group members with required performance monitoring features, not limited by perf event paranoid setting. So doing this way, perf user members, group members, and only them are capable to conduct performance monitoring in the system bypassing limits of perf event paranoid. This specific access control management is only available to root or super user processes that has cap set pcap or cap set fcap capabilities enabled. This kind of control and granting of extended permission performance monitoring privileges this way remains firmly secured. Implementation of mandatory access control for perf via CLinux subsystem relies on support from OS distribution. Access to perf, limited by MAC settings, can be identified in the messages printed by perf utility and also by inspecting log file records presented in the slide in yellow. In order to open access to perf in CLinux, it's necessary to extend security policy settings loaded and used by the kernel. To do that, it's required to generate the policy extension file and load it into the kernel, like presented in the slide in green. Detailed instructions about that can be found in documentation file located at perf tool source code following the link mentioned at the bottom in the slide. Now let's demonstrate perf access control management in multi-user environment. Currently, we are in the root console. Running kernel version is 5.8 with support of cap perfmon. Running OS version is Fedora 31. Perf tool is installed in the system without privileges and available to all users of this system. There is also the same version of perf tool binary but named like perf.cap, available to members of perf users group only. Perfcap executable is also granted with extended performance monitoring capabilities. Perf event paranoid is set to true, what means that monitoring is available in the scope of user processes and at the user mode level only. CLinux is enabled in the system and it's in enforcing mode. Access to performance monitoring is blocked in the system even for root, and the message in the screen tells about possible reasons. In case of root access, it's blocked by CLinux policy, and this can be identified by looking at the system log files. To open access for root, let's extend security policy with module myperf, loading it into the kernel. Operation takes some time. And now access to performance monitoring is open for root. Now let's check performance monitoring features for unprivileged users. Get into vTune console. vTune user is a member of perf users group and has access to perf.cap utility. Attempt to do system-wide monitoring using standard unprivileged perf utility is blocked by perf event paranoid, which is 2. However, system-wide monitoring is possible by perf.cap utility with cap perfmon capability. Now try using perf.cap utility by a user who is not a part of perf users group and see that system expectedly blocks such kind of access. However, users' own processes can still be monitored using standard unprivileged perf utility. That's actually all from my side today. Thanks for your attention, and now I am open to your questions.
Thank you, Alexei. Really, at least for me, complicated stuff. So,
Yeah,
when I see you reference the security risks there, it made me think about something we had to do this summer, which is the European Privacy Directive, EPD, known as EPD, and basically many companies had to revisit their perf monitoring tools and strategies to ensure that they're not logging inadvertently any of this information that the European Privacy Directive was tagging as privileged, right? So I'm curious, when you're talking about security risk, there you're thinking more about actual security risks, somebody being able to perfmon to take over your server, or it's more privacy-related risk? Using perfmon, somebody who would not be allowed to see some privileged information with you.
Okay, good question. If I got it right, so version 5.8, there were no actually a way to make that kind of privileged executable in a secure way, just because you would need to grant the whole CAP sysadmin capability to that privileged binary. But as you know, CAP sysadmin is kind of known as a one more root. So when you provide such a powerful capability to a binary, you actually expand the attack surface a lot. Okay. So, and that was actually the motivation behind that creation of kind of something that would limit that attack surface as much as possible, but at the same way provide users with the performance monitoring functionality. So, yeah, that's the idea.
Got it. So it's the good old-fashioned hacking that you're trying to prevent, that people are trying to prevent against with these settings.
Actually, yeah. So CAP Perfmon, as I said, is actually the implementation of old good known principle of the least privilege. Actually, so the binary will be granted only that capabilities that it will actually need, not all of capabilities that are there specifically in CAP sysadmin capability. Yeah, and Perfmon, this is the solution for performance monitoring, exactly.
And one more question. So I think it's many people say that the most commonly used password is password 123. So I was looking at all these settings for security. How often do you think people actually have the right settings for perf monitoring? Is the default the most restrictive one, or each sysadmin kind of needs to go and decide for himself?
Of course, I think sysadmin eventually decides how to configure the ecosystem and the software which is available to users inside big systems. So, and CAP Perfmon actually provides one more way of exposing precious functionality to users in more secure way, because before we have CAP Perfmon, sysadmins are quite paranoid stuff, and they just can set paranoid to the maximum restrictive level, and that's it. And actually, it's really hard to convince those guys to actually relax a little bit these settings, just to provide the users with the ability to monitor, to tune performance. But actually, the security is, by those guys, is treated as the most important thing, and probably they are right in their intention, just because system is big and users, and there are many different kind of users. So actually, CAP Perfmons, I believe, can actually make the life easier for users and for admins together in that big systems actually. So, but it will see.
Excellent. I'll say thank you so much for your talk and for taking the time to be with us today.